The goal of this experiment is to separate a 1-to-1 mixture of acetanilide and benzoic acid. You will then recrystallize each chemical and analyze them by IR and melting point. Before starting, protective equipment such as safe lab attire, goggles, and gloves are mandatory and must be worn at all times. To begin, 1 gram of a 1-to-1 mixture of benzoic acid and acetanilide are added to a flask and dissolved in DCM. After dissolving, the solution is then transferred to a separatory funnel. Because there are so many steps to this extraction, oftentimes it can become very confusing. It is highly recommended that the flasks are labeled. To extract the benzoic acid from the DCM, 3 molar sodium hydroxide is then added to the separatory funnel. The cap is put on and the funnel is shaken with intermittent venting. The layers are allowed to settle and they are separated. The organic layer, which is the bottom layer since DCM is more dense than water, is then put back into the separatory funnel and washed with 3 molar sodium hydroxide again. The purpose of washing multiple times with hydroxide ensures that it will deprotonate the carboxylic acid to form sodium benzoate, thus going into the aqueous layer. To make sure that there is no acetanilide in the aqueous layer, the hydroxide layer is added into the separatory funnel and extracted with more DCM. The aqueous layer is added into the separatory funnel and additional DCM is added. The cap is put on and the funnel is shaken with intermittent venting. The layers are allowed to settle and the organic layer, which again is the bottom layer, is separated. Once separated, more DCM is then added and this step is repeated. Once the layers have settled, combine the organic layers into a single flask. You should now have one flask with acetanilide and DCM and another flask with benzoate and water. From this point on, you can focus on either chemical, but for the purpose of this video, we will show the complete sequence of each chemical at a time. We will start with the acetanilide. Since the acetanilide is in the organic layer, it is dried with sodium sulfate until it no longer clumps. The solution is then filtered either by gravity filtration as shown here, or you can also use vacuum filtration. Once filtered, the flask is gently heated to evaporate the solvent. Once the DCM is removed, there should only be solid acetanilide left. To recrystallize, the sample must be dissolved in the minimum amount of hot solvent. For this lab, we will be using water as the recrystallization solvent. Water is boiled on the side, and using a pipette, boiling water is slowly added to the acetanilide while swirling to dissolve. Once dissolved, is it allowed to cool to room temperature on the bench. Once it reaches about room temperature, it is put on ice. After about a minute, you should see crystals forming. If you do not see crystals after some time, you probably added too much water, so just simply boil off some of the water. After about 5 minutes or so on ice, filter the crystals using vacuum filtration. For benzoic acid, we must first neutralize the benzoate with acid. The aqueous layer is put on ice, and 3 molar hydrochloric acid is added by pipette. A precipitate should form. This is your benzoic acid. Since it is now organic, it does not dissolve in water. The benzoic acid is then filtered through vacuum and washed with water to remove any excess hydrochloric acid. To recrystallize the benzoic acid, we will again be using water as the solvent. The benzoic acid is dissolved in the minimum amount of hot water. Once dissolved, allow the flask to cool to room temperature on the bench. Once cooled to room temperature, put the flask on ice. You should see crystals forming. Again, if you don't, simply boil away some of the solvent. Once the crystals have formed, filter them through vacuum. The crystals should look nice and shiny. For the remaining part of the lab, both chemicals can be run side by side. The crystals are put on a scale and masked. This will allow you to calculate the percent yield for each compound. The melting point will also be taken. This will help determine how pure and clean your sample is when comparing to the literature melting points. Using a capillary, tap the open end of the crystals onto a small amount in the capillary. You can then turn it upside down and gently tap it so the crystals fall to the bottom. Alternatively, you could also use this big tube. This is also repeated for the other sample. The capillaries are then added to the melting point machine and turned on. Do not turn the heat on too high because this will cause an inaccurate measurement. Looking through the peephole, you should see both samples on the left and the right. Record the temperatures when the sample begins to melt and when it is fully melted. Then compare to the literature values. Not pictured is taking the IR of each sample. Compare them to the original spectra to confirm that you have extracted acetanilide and benzoic acid and calculate the % yield of each.